All right, I would like to introduce Andrew on Ramin Mapp. He is the CEO of Data Analyzers Inc., an Orlando company with a clean room that has the ability to take hard drives apart, get the platters out, put them in an identical hard drive, and get data off if it's gotten unreadable in the computer or tablet or whatever device it's on, even phones, even thumb drives, even SD drives, stuff that I didn't even know existed. So at this point, I would like to just turn it over to Andrew. And if you'll, are you familiar with Zoom? You can share your screen if you want to. If you have a presentation, please let us tell us about your company.
Okay. Yes. Yeah, I do have a presentation I put together. Nothing elaborate, just relatively simple. But appreciate the opportunity here to be here on a Sunday afternoon. And I hope I can share some information about our company and hopefully also answer some questions that may be relevant to any type of data loss or data protection. So if it's okay with you, Stan, I'll get started.
Please do.
Okay, great. All right, everyone able to see my PowerPoint screen?
Yes.
Okay, excellent. All right, so as Stan already mentioned, the name of my company is Data Analyzers. We specialize in data recovery, but in addition to that, we also do some cybersecurity and digital forensic work. By myself, I started Data Analyzers in 2009. I've been in the IT industry for approximately 15, 16 years now, with really emphasis on data recovery and digital forensics and cybersecurity. Various certifications in the field. Some of the older certifications that I early on acquired were Microsoft Certified System Administrator, Microsoft Certified Systems Engineer, and then later on, I've specialized more on forensics and cybersecurity. So some of the certifications I have include the Certified Ethical Hacker, Certified Computer Examiner, Certified Forensic Analyst, and various others. I still says here on the presentation that I'm the Vice President of the Orlando InfoGuard Association. I've actually recently took over as the president there. For those of you who are not familiar with it, it's a nonprofit organization that is spearheaded by the FBI and is a public-private partnership between the FBI and individuals from corporations and organizations all across the country, with the goal really being for a joint information sharing as it's relevant to cybersecurity, as well as terrorism and anything else that's related to really the defense of the nation. So I've been heavily involved in that. I started Data Analyzers in 2009, mainly because at the time I had lost some data and I had problems finding a data recovery company at the time. And when I finally did, they came back and said they couldn't recover it. And so I found that there was a need to be able to recover data, and there had to be a better possibility and better options than I found at that time. And so my journey began into data recovery, and that's where I had started out in 2009. I grew the company from essentially at one point being just myself working from a small office up to last year having 9 employees and a continuum of offices that grew and grew exponentially over the years. I'll give you some more details about data analyzers. As I said, it was founded in 2009, and we recover data that's been deleted, went missing, has been corrupted, or has been damaged due to inaccessibility of the storage device. So literally any type of cause that caused data loss or data not to be accessible, that's really what we specialize and help our clients with. In terms of what we can recover from, typically we tell clients if digital information can be stored on it, we can probably recover it. And the most common recovery type of scenarios obviously are computer recoveries from Macs, PCs, laptops, where there's been either files that's been accidentally deleted, trash bins that have been accidentally emptied, operating systems that accidentally have been overwritten or reinstalled or formatted. And then, of course, the issue of a failed device in the hard drive itself, where the data is no longer accessible because either the computer failed or the hard drive failed or the solid state disk itself failed and is no longer accessible. Of course, we also do external hard drives, USB thumb drives, compact flash, and SD cards, which essentially are the same, are almost the same type of technology. So I usually combine them together as flash-based storage. And what happens with them oftentimes is that either with USB thumb drives, commonly the connectors get broken off because either someone's child, someone's dog, or someone accidentally touched it inappropriately and it just snapped on the connector side. The other issues that happen with those quite frequently is the actual controller of those devices starts to fail, which I usually just refer to as the brain of those devices. And once they fail, then data access is no longer possible. And so we specialize in recovering data from those, both for consumers as well as corporate environments. Then we also do a lot of smartphone recoveries, a lot of iPhones, a lot of Samsung Galaxies and other Android-based phones. But we also do non-smartphones. Occasionally we get older style flip phones that have some important data that needs to be salvaged after the device stopped functioning, and we can extract the data from those as well. Obviously, currently with the trends that are ongoing, smartphones are getting larger and larger in capacity and more sophisticated. So we are seeing more and more clients storing their precious memories, pictures of the children, family gatherings, as well as business documents on smartphones. And we are seeing more and more smartphones fail. A good example, one of the common issues that we see quite frequently at the moment is with iPhones that fail during an update process. And there's really two main reasons that seems to happen. And quite surprisingly, Apple has not built in any safeguards to protect from that. The first one being someone trying to update their iPhone and the phone is actually full or almost full near capacity. And when that download tries to download onto the phone, it literally overwhelms the file system. And what happens is the phone will try to reboot. And after that reboot, it never starts back up. And it's just stuck with the Apple logo flashing, and you can no longer access that data. The second reason that we see this happen quite frequently is when someone doesn't update, and it's not limited only to iPhones, it can happen with other smartphones as well, but that's where we see it most frequently, is when an update is performed and Wi-Fi is enabled, and that individual starts downloading the update and then leaves the proximity of the Wi-Fi or turns off the Wi-Fi, or there's an interruption of the Wi-Fi and the phone tries to switch from Wi-Fi back to cellular mode, and that causes corruptions quite frequently during the update process. And then again, same scenario, you end up with a iPhone that's stuck in what we call the boot loop, and all you see is just a Apple logo, and it will never really restart or refunction. Currently, there's very limited scenarios where a recovery is possible because of all of the security that iPhone has, or Apple has actually built into those devices, and the encryption. So we have, I would like to say, amongst one of the highest success rates with those in the industry, and it is still at about 70% only. So at that point, if you do have an iPhone, or have someone, or have a client that has an iPhone, if it's stuck in this boot loop where you just get the iPhone logo, the Apple logo, and it will no longer restart, it's usually beyond what a mobile phone repair facility can do, or beyond what the Apple Store is able to assist with. Typically, it requires some type of exploitation of the phone. We, in these type of situations, use some mobile forensic tools to do this type of exploitation, but even that is only works in limited scenarios. We do have some proprietary solutions to deal with that. But like I said, even with that, there's about a 70% success chance currently on iPhones. On Android-based phones, it's more like 90 to 95%. But that's a very recent, very common thing that we see a lot. Also, we do a lot of data recovery from servers, both for small businesses as well as for large enterprises, which may include databases, virtual machines, RAID environments that fail or haven't been monitored properly, with multiple drive failures, things of that nature, where there's mission critical data loss. And then some of the other things that we do, not as frequent, but we still see them and get these type of recovery inquiries in at least once or twice a month. One is for backup tapes, and oftentimes those are archaic backup archives from several years, or sometimes even decades in the past, that now for some reason need to be recovered, and the technology has moved on and current backup solutions don't support them anymore. In addition to that, we also, of course, do CDs, DVDs, and floppy disks. When CDs and DVDs are scratched, floppy disks that are producing input, output, and read errors, those are things that we can assist with as well. And then in addition to that, we also do quite a bit of proprietary devices, and this literally can be anything where data is stored on, but usually it's something that's quite critical to the client. For example, we've on numerous occasions recovered data from digital answering machine services that failed. And in these cases, usually what we have to do is actually unsolder the actual storage data chips and extract the data directly from these data chips. Another example, last year we did a proprietary recovery from some type of an oil rig for an oil refinery out of Texas that had a specialized piece of equipment, and it was running a really old type of a hard drive, but it's been solid and was running for over 20 years without a problem. And now, of course, when it failed, it was quite critical to them to get that back up and running as quickly as possible. So those are kind of the common scenarios and media that we recover data from. But like I said, we do quite a bit of proprietary or non-standard type of recoveries as well. But this pretty much covers about 90% of the market in terms of what we do. Some of our clients that you may recognize include the Tampa Buccaneers, UCF, of course, since we're local here, Hard Rock Cafe, which also is a local client since they're Florida based. We've done recovery work for IBM, Darden Restaurants. We've recovered data for the military on numerous occasions, including the National Guard, including the Navy, including the Army, and various other groups and organizations. Some of them I can't list due to non-disclosure agreements, but let's say banks' data oftentimes fail as well. So they're not always as reliable as you would anticipate. We do have a ISO class 100 certified clean room environment. What that means, the ISO 5 standard means that there's less than 100 dust particles per square cubic foot that are allowed during these type of measurements. And so the way this works is with HEPA filters that filter out the dust particles out of the air. This here is actually one of our engineers, David, working in one of our laminar flow benches in the clean room on a hard drive. Here's an older picture of myself working in the clean room on a hard drive. And essentially why this is important is because hard drives are extremely sensitive. And if they're opened outside of a clean room environment, even if the air and the room is clean and would be considered sterile, there are dust particles all over in the air, even though we can't see them. And what happens is they quickly will start setting onto the platter surfaces of the hard drives, and then it contaminates the hard drive, and it drastically starts decreasing the chances of being able to recover the data. And so that's why we, as well as most other, or pretty much all other professional data recovery companies, will advise against opening up a hard drive outside of a clean room environment, because once these dust particles start settling, it becomes really challenging to remove them, and makes the recovery so much more difficult and challenging. Now, as an example, I wanted to show here our traditional hard drive that we have here on the left. And in this case, this is a 2.5-inch IDE hard drive. And then on the right, we actually see a SSD drive. So the main differences are, someone wants to join, let's see, all right. The main differences are that on a hard drive, we have mechanical components that rotate. And on a solid state drive, we only have chips where data is stored in chips. For a long time, there was always an assumption that data is really stored on zeros and ones, but that was never actually accurate up until the recent development of NAND and NOR-based storage that's used in flash drives. So despite those were common terminologies that were used, data was actually not stored in zeros and one and in digital format on a hard drive, but rather what you have on the hard drive, you have multiple platter surfaces, and usually most common scenarios, you'll have 2, 3, or 4 platters depending on the size of the hard drive. And then you have a top surface and a bottom surface on each hard drive, and data is actually stored magnetically. So there's a magnetic coating on each surface, and then on top of that magnetic coating, you have several additional layers of coating, which are pretty much just protective coating and lubricant coatings. The platters typically are made either out of glass or out of ceramic. And then you have this layers of very fine and delicate coating, and then the data is actually stored magnetically. And that's why what happens when you read the data from these platter surfaces, it actually creates a magnetic field, and it's actually an analog signal what you receive through this feedback loop for the reading process. And so what happens is you have this analog signal that you're reading out, and you have these heads that hover slightly above the platter surface, just high enough to not make contact with the platter surface as they're rotating at a very fast frequency. Usually on a 2.5-inch drive, it's usually about 5,400 revolutions per minute. On most 3.5-inch drives, it's 7,200 revolutions per minute. But those are typically what you see, 5,400 and 7,200. And on SCSI drives, those are larger. You will see 10,000, sometimes even 12,000 revolutions per minute. So you're rotating extremely fast, and you have this magnetic impulse where the data is written to and read from the actual platter surface that is stored in magnetic impulses. It's read out, and then what happens is this analog signal gets fed to a read channel, where now this analog signal is converted into a digital signal and is then fed to the computer. So it is not a digital signal, it's an analog signal that then gets converted inside of the hard drive. I'm sure all of you have seen a hard drive, inspected a hard drive before, and you flip it around, you see the electronic components. One of the functions of those data chips that you see on there is the translation of the analog into a digital signal. Now, on the solid state drive, you have none of that happening anymore. So their data is truly stored digitally in zeros and ones. And as you can see in the picture there to the right, you have on a solid state drive numerous of these NAND chips where your data is actually stored on. Okay, this is the PCB for a hard drive like the one we see on the left, although this is actually for a 3.5 inch. So this is what I'm referring to. In this case, the read channel would actually be part of the main controller chip, which is the big squared chip that you see. And there's a lot going on behind the scenes with the signals to prepare those to actually get them to the point where a computer can actually recognize that signal. Obviously, there's a lot of damage that can occur to various aspects of these electronic circuit board. There's a motor controller that at times can burn out, in which case it will lead to the platters not being able to spin up anymore. Some of those are designed better than others, and they have some diodes on there, and they will have actually some protective mechanisms, but unfortunately not all of these printed circuit boards have these, and it's not even where you can say it's based on a particular brand that carries them or a brand that doesn't carry them. But some of them will have fuses to protect the circuit board, and if there is a spike in amplification or voltage, the fuse would protect the board. Those that don't have this fuse, what happens is the board itself will suffer significantly. Now, this is the underside of where the PCB, the electronics board, connects on the hard drive. As you can see, there's basically 4 little connectors in the center. 2 of them are actually for the motor, and the other 2, one being for a reading and a writing. Actually, my apologies, that's not accurate. Those 4 you see in the middle are all for the motor, to spin up the motor. And to the left bottom, where you see these pins that are in this protected little bubble, that's where your actual data signals travel to the electronics from the internals of the hard drive. So your reading and writing signals. On the hard drive itself, you have the electronics that we already covered. You have the platters, where you can see one of them exposed. You have the actual chassis or the actual enclosure, and then you have the actual head stack assembly, which you see to the bottom right of the picture, which you can imagine almost as being like a needle on a record player, with the main difference just that it floats rather than actually making physical contact. Now, this here is a picture out of our lab where there is a hard drive that suffered from severe media damage. And this is a scenario that happens quite frequently, where the heads stop floating above the platter surface, and they will actually start making contact onto the surface and will actually start scraping away your data. So pretty much a worst case scenario that anyone wants to deal with, both from a recovery perspective and of course also for a client, because Sometimes they're recoverable. In many cases, they're not recoverable, or only partial recoveries are possible, and it can be quite costly and complicated process. But this happens when these heads start making contact. And if you ever hear a grinding noise, that is an immediate sign to shut off the hard drive, because that is exactly what's happening here, is it's grinding away the actual data from the platter surface. Here is another picture from a different case from our lab. And you can see here that there's lots of debris on the right side of on the right picture. There's a lot of debris, which is not actually dirt or anyone that opened up this hard drive outside of a clean room. This is actually what we call platter dust. This is actually the data that's been grinded off because it continued to rotate and run while the heads have made contact with the platter surface, and literally scratched off all of the data off of that surface. To the left, you will see a filter. All of these hard drives have actually a filter inside of the internal chamber, and these filters should be white. And as you can see, this filter has a lot of gray and a lot of dust, which essentially is data. So in this case, when the client asked where the data was, we unfortunately would have had to refer to the filter, and spreadsheets and pictures are now in the filter, no longer on the hard drive, unfortunately. So these are some of the scenarios of what happens when you hear clicking and more importantly, the grinding noise. Now, the clicking noise usually indicates that there is a mechanical issue. Back years ago, that wasn't always the case. There were various other scenarios where a clicking could potentially be caused by the electronics or by firmware issues. Nowadays on modern drives, if you hear a clicking on a drive, about 90% of the cases, it's actually going to be a problem with the read and write heads, that they have failed. And when they failed, oftentimes they start to bend. And if they bend, again, what happens is they can make contact with the platter surface and start scratching and grinding off the data surface. So one of the things that we see, one of the mistakes that we oftentimes encounter is where someone runs data recovery software on a drive that's suffering from mechanical issues. If a drive is only suffering from some bad sectors where it occasionally hangs, data recovery software sometimes can be helpful. But once a drive develops more severe issues, oftentimes what happens is these tools will continue to run, and they will continue to stress the hard drive that's already in a very fragile and dire condition, and it can lead to the hard drive fully failing, and or it can lead to platter damage. So therefore, that's really where someone with the proper experience wants to diagnose a hard drive to know what exactly is going on with it, rather than just running some tools on the drive that potentially can make the situation worse. And an example what I'll give here is commercial tools that you can obtain. Typically, what happens is they will interface with your Windows computer drivers, or with your Linux drivers, or they will interface directly with the BIOS to read information from the hard drive. All of those are high-level access attempts to the hard drive, which has a lot of overhead and a lot of burden to the drive itself. When it comes to professional data recovery, we use specialized equipment to perform these type of procedures. And what we end up doing is the tools that we use interact directly with that chip, the controller chip, the square one, and basically bypasses Windows, Linux, the BIOS, and sends signals basically directly to that chip to really reduce the amount of stress that you're causing to the hard drive and these heads that are already having malfunctions. All right, so this is a picture that not many actually get to see. It's a close-up under a microscope of an actual read-write head element of the drive. So this is the actual component, what you see in the center there, that has this somewhat weird shaped pattern. This is the actual read and write element that's responsible for reading the data out. Now I think this is a 30, I think that's a 30 times magnification here for that particular picture. So that gives you an idea of how small these components are. And if you were to touch this read and write head, it's extremely sensitive. If you were to touch that, it immediately would fail and would be damaged. Even in earlier days, what you could do, of course, under a clean room, sometimes these head elements would be dirty. They would get dirty and therefore couldn't read anymore. You could take a fine toothbrush and run them over these read elements to clean that out. But on modern drives, you're not able to do that anymore. It immediately would damage these read and write elements. So these are extremely sensitive, both to any type of touch or contact, as well as to ESD, any type of electrical shock. So being absolutely grounded is also a requirement when doing any type of work with these type of hard drives. And hard drives have become more complicated to recover from, because what has happened over the years is you have the same amount of real estate space essentially on the hard drive. So a hard drive has not grown in diameter. The platters are still, you still have the 2.5 inch for the laptop and the 3.5 inch for the desktop. Also, they have not gotten longer, higher. The form factors have stayed consistent, but the amount of data that's been stored on the hard drive has increased by several hundredfolds over the last few years. So more and more data is being stored on the same actual physical space, and therefore there's a higher density on these hard drives. And every year there's a higher and higher density that gets built on the hard drives, and therefore these drives are actually more prone to errors. And then to be able to actually read these high density signals, they also have to lower the read and write heads to be even lower to the platter surface. And so therefore it also increases the chances of these heads making contact with the surface, especially on external drives when these drives receive any type of shock, if they're accidentally bumped, even if they're moved around while operating, it can cause these type of issues. All right, so here's another picture of a SSD drive. We can see here there's 8 similar chips. These are the actual data chips. Then there is one Samsung chip, a black chip to the left. I'm referring to the top one. This is actually the brain, the controller of the device. And then there's a smaller Samsung chip, which is a rectangular kind of looking chip. That actually is the RAM for the drive. And so those are the main components of the SSD. And if the brain of the device, the main controller, fails, it obviously is not able to read anything from the data chips. So in this type of scenario, what we have to do is actually unsolder the actual individual data chips and read out the data directly from the chips, and then reassemble them back together, which ends up being this huge puzzle and is a very time-consuming process. So here the takeaway is the SSD drives are more reliable than hard drives in the sense that they're not prone to physical failure. They're not prone to the wear and tear that hard drives are. Also, if you accidentally drop an SSD drive or it receives any type of shock, it really does not affect it. However, there are also failures that affect SSD drives. In particular, now it's all electronic, so they're prone to electrical failure. Any components on the electronic board can fail. In addition to that, they have a lot of firmware issues where firmware corruption occurs, where the device will no longer function. And then the other interesting thing or component about it is that there's a limited read and write cycle to these chips, the actual data chips. So in this case, these 8 chips that we see there, there's only a limited amount of time that you can actually write to these chips before they are worn out. And once that happens, they fail and your data is also no longer accessible. So SSDs, good in some sense, but certainly not as reliable as some would try to lead us to believe. So we are seeing more and more SSD drives in that we get for recovery, and failure ratio, it's a bit hard to define. Generally speaking, I would say less failures than hard drives, but still a significant amount. All right, that was pretty much all I had, so I'm open for any questions.
Mike Ungerman. Actually, my question is on your last screen. Given a typical desktop computer, where your operating system and your programs and any direct data that the programs need to use are on an SSD, and then you have a fairly large standard hard drive for your data. And the majority of time, that standard hard drive is just sitting there idling and turning, and your heads are just sitting there floating, as opposed to the majority of the time, say, were you to replace that standard hard drive with an SSD, it's just powered on and not doing anything except its normal checks, with the operating system and the trim that's running. So under something like that, I have considered taking a 1 terabyte standard hard drive and replacing it with a 1 terabyte SSD. Given the prices of 1 terabyte SSDs now, I'm just looking at one on Amazon that's $83.50. So from a reliability standpoint, if I'm making regular weekly backups, am I taking a risk by going to an SSD, or am I better off staying with that mechanical hard drive?
It's a good question, Michael. I would say you're probably better off with the SSD, especially if you're making frequent backups of your data, because you have actually, you're drawing less power from your computer, so you're saving money. Your power supply is less in demand. And like you said, this SSD is not going to idly work as much as the hard drive. And like I said, with the exception of any trim activity, which again is also based on there being data blocks that are being occupied or freed up. If you're not accessing that, let's just call it your D drive, quite as frequent, then you do have a lot less read and write cycles to the SSD, and so therefore you certainly are preserving that, and then you're gaining the benefit of the increased read and write performance from the SSD. So I probably would make the switch to the 1 terabyte SSD.
And then sort of related to that, I recently rebuilt my desktop computer with a new motherboard, new AMD chips, and it came with the NVMe slots on the motherboard. And so I went ahead and put a 500 gigabyte NVMe solid state drive on the motherboard instead of putting a traditional solid state drive and just using the data connectors. Are you seeing any difference in reliability between a standard SSD, 2.5 inch SSD, and the new, I guess I'd call them circuit boards, if you will, the NVMe circuit boards that are on modern motherboards today and in a lot of notebooks?
Right. It's good. Another good question. I would say that a lot of it in terms of reliability really comes down to the manufacturer that you're using and the quality of the chips that they're using. So sometimes these SSD manufacturers will use high quality chips from Thailand, for example, and sometimes they'll use very bad, low quality chips that produce a lot of read and write errors on the chips themselves that they get from cheap knockoffs or relatively cheaply acquire from China. So a lot of it really depends more so on the components that they use. You know, kind of similar to if you're. A lot of people always ask, "Oh, should I buy an HP computer or should I buy a Dell computer?" And in the end, oftentimes a lot of it comes down to the components. Well, what hard drive brand is this HP computer using? You know, what motherboard is this Dell computer using? So it's very similar in the SSD market. Generally speaking, the NVMEs are more difficult to recover from. And so therefore, if I were to build a computer, and I have recently built another computer, I have used an NVMe chip, but typically I will use that only for the OS and for programs. And then I will store any actual data that I want on a separate solid state drive that has a regular SATA connector, and then ensure that I have weekly backups as data changes.
Okay, I'll hit you with one more and then turn it over to anyone else that has questions. During our Windows SIG earlier, I don't know how soon you joined us in our discussions, but Huey Poplock showed one presentation where it stated that in the October update for Microsoft Windows, they are coming with diagnostic tests for NVMe type SSDs to report on their health. Are you familiar with that and how that would actually work?
I'm not too familiar with it. I've heard of it, but from my understanding, it's probably similar to Smart and Trim. It's probably feeding off of that information. So I don't think it's actually anything proprietary. I think it's just pulling those smart logs to give an early notification if there's any read and write errors, for example, overheating of the chips, these type of things.
Okay, thank you very much.
Sure, my pleasure.
Anyone else with questions?
Yes, I'd like to ask which brands of and models of hard drives are the least reliable and most reliable, and same for solid state drives, so that we can purchase and use the most reliable. Okay, well, on the hard drives, it's relatively easy. Seagates are, and we're talking about current drives, not back maybe 5 or 10 years ago, because that was very different. But currently, if we're speaking 2018 to present and to probably 2022, Seagates are pretty much the worst drives, both in terms of failure rate as well as in terms of the amount of platter damage that they suffer from.
So I would stay away from Seagates whenever possible. In terms of drive quality, I typically would recommend Western Digital drives. They do have amongst the least failure rate, and when they do fail, chances of recovering the data are significantly higher than on Seagate drives in general. So you want to look at it both from a perspective of what device fails less frequently, and then, well, if it fails, if I do have this unfortunate scenario, what type of situation, where am I going to be better off with in terms of if I have suffered some type of data loss and I need to get it recovered, what's going to be the better case scenario where chances are going to be higher to recover that data, and that definitely would be Western Digital drives. And a lot of it has to do with, I don't know if you remember, a few years ago, there was this massive flooding in Thailand that happened, and it had drastically impacted two of the Western Digital manufacturing facilities. And so Western Digital was not able to manufacture anything from Thailand for quite a long time. So Seagate ended up taking that opportunity and ended up flooding the market in the absence of Western Digital with low quality and low price drives that they've, for the most part, stuck to. And so the same architecture and design, they've pretty much continued with that. Now, in terms of when we're talking about SSDs, generally the Samsungs are usually good. So the Evo, I usually would recommend like an 840, 850, 860 Evo. Those are definitely amongst the better ones in terms of the quality and the quality of the chips that they use, as well as the integrity of their firmware. They seem to have fewer failures than some other brands, like Crucial, for example, has relatively frequent issues with their NAND data chips. Did that answer the question? Any follow-up questions on that?
I just want to say thanks for some great information.
Yes, that was very helpful. Thank you. There are a variety of brands, and some of them are well known. You know, like Western Digital bought SanDisk, but if you look at SSDs, they appear under both of those brands, although they're made by the same company. Probably could be different technology or different types of architecture inside.
To make a quick comment on SanDisk SSDs, they are good. However, there is a caveat with SanDisk SSDs, and that is that they encrypt the actual data on the actual storage chips. So you are not able to unsolder the storage chip and actually read out anything that later on can be reassembled. And so therefore, there are some exceptions, but generally SanDisks will be amongst the most challenging to recover from, even though they're of good quality and you don't have many failures. When they do fail, you're in big trouble.
You had mentioned your association with data forensics and the association that you belong to, or that you're the president of. Obviously, there was a lot of information in the news over the last 3-4 years about bleach bitting hard drives and making data invisible to intensified recovery efforts. Is it actually possible today with software that's available, at least to technology companies, to wipe a hard drive such that the data is not recoverable with forensic methods, even at the level that NSA might have?
Absolutely. And a lot of it has to do with the density of the drives, that the density has gotten so high. There used to be a technique that was developed where through microscopy, they would be able to identify a bit that was turned on, even if it's turned off, because compare it on entropy between a bit that was not turned on at all versus one that was recently turned off, there is a distinction. However, that was possible on drives that were 40 and 80 gigabytes in size. That is not happening on a 2 terabyte, 3 terabyte or greater drive anymore. It's just not possible. I mean, it's not possible currently. With machine learning, I wouldn't be surprised if it will be possible again sometime in the future. But currently, it's not possible. And it's the same, for example, with an iPhone when it's factory reset. Not even the NSA is able to get any data off of that. Just gone.
Okay, one more question. I don't know that it's your specific specialty or not, but we have lots of cases. I know Bob is familiar with this, where ransomware takes over a computer. And, for an individual, there's not much they can do except perhaps, doing a full image recovery. But it never ceases to amaze me that corporations such as banks and hospitals are actually paying the ransom, yet they have corporate systems that one would think is backing up all their data on a regular basis to RAID arrays, commercial RAID arrays, things along those lines. And I tend to wonder why these companies are not using sophisticated backup routines or the recovery capabilities for their systems. Is this anything that you have insight into?
Actually, I do, and something I've dealt with quite extensively. So a few things started to happen. For one, the ransomware attacks have gotten more sophisticated because these cybercrime gangs, they typically come out of Russia and out of the Ukraine. They do have some other groups now that some nation states are doing these type of activities, such as supposedly Iran and North Korea. But still, bulk of this activity still comes from the Ukraine, Russia, and any former USSR, Russian nation members, such as Georgia, Estonia, Latvia, that entire region. And since chances of getting caught with these ransomware attacks have been very low compared to other type of criminal activities, and the revenue that they've been able to generate from these type of attacks have been so significant, they consistently are increasing their aim and the sophistication of these ransomware attacks. So it used to be just 2 years ago where these ransomware attacks were literally submitted via email, and if you clicked on one of those email links, now your computer would be infected. Now they've gotten onto the offensive, and they're actually actively hacking into corporate networks. Once they hack into these companies, now they're actually deploying these ransomware files directly in the network, so they're actually taking the extra step of hacking into it. So that was a next step of sophistication, and they would encrypt the data. Then the follow-up next step in terms of sophistication was they would encrypt the data and then they would search around on the network for where backups are stored, and then they would encrypt or delete those backups. And that's pretty much what's been forcing a lot of these companies to pay the ransom, is because their main data is encrypted, and what's supposed to be their backup data was also somehow accessible from the network, and it's been deleted. And that's where we, in some situations, can come in and help recover the data that's actually been deleted. They're recovering their actual backups, but it's not always as cut and dry as it may initially appear. But those are some of the reasons. Also, a few years ago, there's been an industry trend to step away from tape backups. And of course, there's still a lot of organizations that use tape backups, but the trend was disk backup. And they created these virtual tape libraries, for example, which functions just like an old backup tape library, but it's actually all on disks. With the benefit being you can back up and restore much, much, much faster. But now, of course, the drawback is that those are accessible from the network and are easily accessible by these cybercrime gangs.
Thank you. I might suggest that you go up to the top of your screen and turn off screen sharing.
All right.
Back to you, Stan.
Yeah, wow, that was fascinating. Andrew, really appreciate you taking the time and sharing your knowledge with us.
My pleasure, Stan.
Well, if there's no more questions for...
Yeah, this has been great. A different aspect than we normally get. Bob G, who's on, is quite knowledgeable on security, but this isn't things that we normally talk about at some of the meetings and some of the sessions and so on. It's been very enlightening. Thank you very much, Andrew.
This is going into forensics and that kind of stuff, and most people never get involved with forensics. That's a totally different.
That could be an entire another discussion for another Sunday.
Yep.
Yeah.
Thank you, Andrew.
Okay.
Yes, thank you very much.
Thank you for having me, and hope everyone enjoys the rest of the Sunday.
You too.
Perfect.
Thank you.
Likewise, for sure. Thanks. Okay, well, if there's nothing else, I guess we'll wrap it up. I am recording this. I will get the link to it. We'll put it up on YouTube, but the Computer Society does have a YouTube site, and I'll get the link out to that within a day or two, hopefully. So I guess with that, if any other announcements, anybody else have any thing they want to discuss?
Don't forget Monday's Tech for Seniors.
Yep.
Some of us won't.
It's been a long afternoon, but it's been interesting.
Yep, it has been.
Yes, for sure.
And I hope you keep your power, Huey.
Awfully
I hope
cloudy
so,
here, but yeah, good luck, Huey. And okay, we'll see you next time. Thanks for everyone, and I'll stop the recording and let that do its thing, and we'll see you next time.
All right.
Bye-bye.
Right. Bye-bye.